Hello, my friends. I'm Clover. This is Genuinely Approachable Sudoku, and today we're solving Just Kidding by Philip Newman. So we have normal Sudoku rules. So we're placing the digits 1 through 9 once each in each row, each column, and each outlined region. And then also we have some region sum lines in the grid. So typically in a region sum line Sudoku, you have these blue lines and each of them passes through 2 or more different regions in the grid. And within each region, the sum of the digits along the line are the same. However, in this particular puzzle, all of the blue lines pass through exactly 2 different regions. And also, they all have one cell that is the only cell on the line in its region. And that means effectively this is also an arrow Sudoku. So for instance, this 7 is the sum of these 3 digits. Whatever this is the sum of these 2 digits, and so on. So let's start with the longest lines. So 7 is the sum of 3 digits. That must be 1, 2, and 4. No other way to do it. 8 as the sum of 3 digits, well, we've already used a 3. So these two have to sum to 5, and they can't include a 3, so they must be 1 and 4. This has to be the sum of 3 digits, so it's at least 1 plus 2 plus 3, which is 6. So it has to be 6 or greater, but it already sees a 7, an 8, and a 9, so it has to be exactly 6. Which is 1, 2, and 3. Same rule over here, sees a 7, 8, 9, so that's going to be a 6, so it is 1, 2, and 3. Now, the only way to make 9 without using a 1, 2, or 3 is 4 plus 5, and that's also going to be the case over here, which will resolve this. That makes these 2 digits 7 and 9, and makes these 2 digits 8 and 9, and this resolves to a 9 because it sees an 8 right here. And that sees a 7. So there's our 7. Now let's look at these columns, column 3 and column 7. So in column 3, we need a 1, a 3, and a 5. That can't be a 3, that can't be a 1. So the 7 is either 3 plus 4 or 5 plus 2. It can't be 5 plus 2 because there's a 2 in column 2 already. So that is a 3 plus 4. So we can eliminate 3 there. Here we're going to need a 1, a 2, and a 3. This can't be a 1 or 2, so it is a 3. And this can't be a 1 or 3, so it is a 2, making that a 1. The 1 resolves this into a 5. So this digit now is equal to 5 plus something, so it's 6, 7, or 8. It could be 6 is 5 plus 1, 7 is 5 plus 2, which isn't going to work because there's a 2 right there, or 8 is 5 plus 3, which also won't work because there's a 3 right there. So it's 6 equals 5 plus 1. Now here, a 9 sum without a 1, 3, or 4 is going to be 2 plus 7. And we still need a 5 and 8 to finish the region. 9 sum without a 1, 2, or 4 has to be 3 plus 6. And then these are going to be 5, 7, and 8. That can't be a 7 because it sees a 7 in its row. That can't be an 8. Now in this row, we still need a 1, a 5, and an 8. This can't be a 1, so the only way to make this work is for it to be 7 equals 2 plus 5. Which resolves the rest of this row and the rest of this region. In this region, we still need 3, 7, 8, and 9. 3 can't go in any of those cells, so that's a hidden 3. This is a hidden 8 because we have an 8 right here. And these resolve based on what's already in row 1 and row 2. We need a 6 and an 8 to finish the row. And we need a 5 and a 9 to finish this row. In this row, we still need a, well, here we can just mark a 7 there because it's 8 equals 7 plus 1. And we also need a 3. These are going to be 4 and 9 to finish the column. These are going to be 7 and 8 to finish this region. Here I need a 5 and a 9 to finish the row. And a 6 and a 2 to finish the region. So now let's finish off with our central region. We need a 1, a 4, and an 8 here. That's a naked 8, 4, and 1. Here we need 2, 6, and 9. And our last 3 digits are going to be 3, 5, and 7. And that is how you solve Philip Newman's Just Kidding. Hope you guys enjoyed that one. The link to check it out yourself is in the description below this video. And I will see you again in 3 days.